OpenWRT is a powerful operating system that turns your Raspberry Pi into a router. This video will show how we can access the OpenWRT network remotely with a VPN. The problem we are trying to solve here is, say you have a Raspberry Pi as a router running OpenWRT. Let's pretend we are in a remote location and we're unable to reach the Raspberry Pi. How can we bridge the gap? By creating an OpenVPN server in Amazon's EC2, we can have the router be accessible through a VPN. With some adjustments to the router's firewall settings, we will be able to allow devices on the OpenWRT network to communicate with devices on the OpenVPN network. Our Raspberry Pi acting as a router will initially have two network interfaces. The first will be the physical Ethernet port, which we will use for the OpenWRT LAN, and the second will be exposed with a USB to Ethernet adapter. The USB to Ethernet adapter will be plugged into your network at home. We will call this the WAN or Wide Area Network Interface. The physical Ethernet port on the Pi will be called the LAN interface or Local Area Network. Finally, the Raspberry Pi will have a third interface which will have traffic pass through both WAN and LAN. This will be the VPN interface. Clients connected to our OpenVPN server on EC2 will be able to reach the OpenWRT network in green through the LAN interface. So in summary, the Raspberry Pi will have three IPs. The first one being the Wide Area Network or WAN. The next one would be the LAN. And then the VPN interface connected to OpenVPN. To get started with your VPN server, sign into AWS. And then from the landing page, go to EC2. The first thing we're going to do is we're going to create a security group for this VM that we're going to create. So at the top right corner, just go to create security group. And the name I'm going to give it is just the date. And then learning OpenVPN, something like that. And then down here, we're not going to touch outbound rules, but we're going to add a couple inbound rules. So the first one, TCP, and this will be on port 22 so that we can SSH into our VM. And then we'll say anywhere IPv4. The next one we're going to do is UDP. This is going to be all VPN traffic, and we'll make it port 943. So if you're connected to the VPN, this traffic will pass through the EC2 instance on port 943. And we can just have this be anywhere IPv4. I forgot to add a description. I'll just say learning OpenVPN and OpenWRT, like so. And then let's go ahead and create the security group. Nice, so we created it, and then let's go launch our instance. With our security group created, let's go ahead and launch the instance. So in the top right corner on the instances page in the EC2 section, make sure you pick a region that's closest to you. Go ahead and launch an instance. I'm going to call this the same thing as the security group, just the date. So 2022-08-25 OpenVPN. Let's just do server like this. Down here, the image that we're going to use is Ubuntu. And then we're going to create a new key pair, 2022-08-25 OpenVPN learning. Go ahead and create the key pair. Nice, it'll save to the computer. When it comes to the section for security group, go ahead and select the one that we created earlier. And the storage is fine. And then let's go ahead and launch the instance. Now that the EC2 instance is up and running, let's go ahead and connect to it so we can install OpenVPN. Go ahead, click on the instance, and then go to connect. If you click on SSH client, you'll be prompted with this example SSH command. You can go ahead and copy it. It should be the same for Linux, Mac, and Windows. I'm going to go ahead and SSH into it through Windows, but the command should be the same no matter where you're running it from. To get into a terminal on Windows, I did window R. I typed CMD and hit enter. I'm in the terminal now. Let me CD into my downloads directory. And then I'm going to paste the command that I got from the web page right here. So I paste it with right click. That's if you're on Windows. Next thing is I'm going to hit enter, and then it'll say, are you sure you want to connect? Hasn't seen it before. Just say yes. And then there you go. I am in the VM, and things like ls and uname-a work. And you can see that I'm on Linux, Ubuntu. In order to install OpenVPN, we can make use of a bash script that takes care of all the heavy lifting for us. You can find it at git.io/VPN. If you want to go to the actual repo, just click or highlight this link here, open it up, and then how to install this, it's this command right here. Go ahead, copy it, and then paste it into the EC2 instance. It will download this bash script, and then we'll use it to install OpenVPN, as well as add and remove clients. So it says I need to rerun it with super user privileges. But doing ls, you can see that the file's in there. And you can cat the file just to make sure that it's a bash script. Nice. Looks the same as this raw GitHub. Cool. So let's go ahead and sudo, let's give it execution access. So openvpn install sudo and then openvpn install.sh like that. It'll prompt you, it'll ask you some things like what's the public IP address, just hit enter. We want to use UDP. The default port is 1194, but I did 943, so I'm going to do 943. The DNS server we'll use, let's just hit 1, it'll default to whatever the system resolvers are. First client, I'll just do my name. And then it's ready to begin, so I'll just press any key and then it'll install everything for me. After successfully installing OpenVPN on the EC2 instance, there should be a script here called openvpn-install.sh, which is in your home directory. So if you do ls, you'll see it. You can run it with sudo and then / the file name. If you hit enter, the script gives you some options. So if you want to add a new client, manage clients, remove OpenVPN, it's all very easy. When we first installed it, it created a single client with just my name. I'm going to keep that one because I'll use it on my computer to test out our remotely accessible network when we're done. Let's go ahead and create a new client, which will be for the OpenWRT router. So I'll hit 1. It'll ask you for the name, and I'm going to just put OpenWRT router. And then it'll automatically generate it. You can see that it was created here in the root directory. So if you just do sudo ls/root, you'll see that there's 2 files here which corresponds to the 2 clients that we've created. So I'm going to go ahead and cat this file here and then paste it into a file on my local machine. So let's go ahead and do sudo cat root and then openwrt-router.ovpn. And then this is the whole thing that we need to copy and paste. So copy this output to a notepad file or whatever text editor you like, and then go ahead and save the file on your computer as openwrt-router, the same name that the EC2 configuration file is, .ovpn. With OpenVPN installed now, I'm going to make some changes to the server's configuration file. To do this, we'll do sudo vi etc openvpn server.conf, like so. And the couple things that we're going to change in here. First one is to remove this line here. This line here basically says route all traffic through the VPN when you're connected, when we don't really want to do that. Our intention of this is just to access a single network. So I'm going to remove that. If you want to keep that, you can. It's just less traffic running through. So next thing is I'm going to change the DHCP option here. When I was setting it up, I said to use the current system resolvers, but really you can do Google's DNS or 1.1.1, which I believe is Cloudflare's. Cool. Next one, let's go down here. And then we're going to add a couple more entries in here. First one is client to client, like so. And the next one is client config directory etc OpenVPN CCD, like so. What client to client does is it says that we want anyone connected on this VPN network to be able to pass messages between each other. And then the client config dir, I will explain a little later with some visuals on why we need this. The last thing we'll add to the server.conf is 2 more lines so that while we're not routing all the traffic through the VPN anymore, we will be routing the traffic that needs to reach the OpenWRT LAN. And those 2 lines are route 192.168.100.0 and then the net mask 255.255.255.0 and then that same line again, but at the beginning we'll have push and then in quotes this is so that the clients and server will know to route through ton 0 or whatever VPN network interface they have when it comes to talking to this subnet here. Cool, so I'm going to save and quit this now. And then the last thing we're going to do is create an entry in the CCD directory on the OpenVPN server. And to do this, I'm going to do sudo make directory etc OpenVPN CCD like so. And then we're going to create a file in there. And this file is going to have the same name as the config that we generated for the Raspberry Pi router. So in our case, we called it openwrt-router. And then in here it's going to be a single line iroute 192.168.100.0 and then the net mask 255.255.255.0. Now, I've read that in order for these changes to take effect, one thing you can do is do sudo etc init d openvpn restart, like so. And then if you check the status of the OpenVPN service, it says it's restarted, but I found that the changes don't actually take effect. One way to do this for sure is to just reboot the EC2 instance. And if you're seeing me doing this and you're thinking that's overkill, please leave a comment if you have something that works that isn't rebooting. But rebooting isn't that big of a deal. The VM is usually back up in less than a minute. Now let's talk about CCD in regards to OpenVPN. CCD is short for client config dir, and the example we used in server.conf was client config dir with dashes etc OpenVPN CCD. This specifies a directory for client-specific settings, and when clients connect to the server checks if there are entries in etc OpenVPN CCD. The naming for these entries should match the client name. So for example, when you ran the script and you specified the client name to be Evan or openwrt-router, the files in CCD should have the same name. An example would be, let's say we created a client called Bob. Bob connects to the VPN server, and the VPN server checks to see inside of the CCD directory if there's an entry called Bob exactly. And if it does, it'll load the settings that live inside of the Bob file. iroute is an example of one of the options that lives in these files. So for example, the CCD file that we created called openwrt-router, we had an entry in there called iroute with the network ID and the net mask. This basically tells the OpenVPN server to route traffic destined for that subnet through the VPN and onto the client, specifically the OpenWRT-router client. In the interest of time, this video will skip the initial setup of OpenWRT on the Raspberry Pi. And by that, I mean flashing an SD card and configuring the USB to Ethernet adapter. There is a really good video on VanTech Corner that covers this, and the link is in this video's description. I created a GitHub repository alongside this video so that all the stuff we write lives here for reference. One of the things I uploaded was how the OpenWRT router should look after you follow VanTech Corner's tutorial. So if you don't feel like following it, or to verify go ahead and download this. I'm going to click on the commit, and you can verify the hash against the link in the description to ensure that you're downloading the same backup as me. I'm going to go ahead and download it, go to view file, and download. Cool, so download it down here to my browser. I'm going to go over here. In the other tab, I have the Lucy web app open. I'm going to upload this backup to ensure that it's legit. Whoops, I accidentally generated an archive, but let's upload the archive. And that's this one right here, this one that I just downloaded. The names match with what we downloaded over here. So upload it. It'll say, yeah, do you want to change all this? I'm going to say yes. This will reboot, and in a moment it'll prompt me to sign back in. When we do so, I'll make sure everything looks good, specifically the firewall and the network interfaces, and then we'll be able to move on and start installing OpenVPN and exposing our LAN to OpenVPN. So it's going to prompt me to sign in here. The default password is pleasechangeme, and it's in the video's description. We can see that it worked and I signed in. Let's go look at the interfaces. There should be two. The first one's the WAN, which is your home network. In my case, this is the subnet for my home network. And then your LAN, which I'm going to go with this subnet where it's 192.168.100. And then, so this all looks good. We're getting traffic on both. The packets are increasing. And then let's go check the firewall. Yeah, everything here looks good. One last thing to double check back on interfaces is if you go on the left side here, WAN should be ETH1 and then LAN should be ETH0. This corresponds to the physical Ethernet port that comes on the Raspberry Pi, and this has to do with the USB to Ethernet adapter. Let's start by installing OpenVPN on the OpenWRT device. We can do this through the interface by first going to System and then Software. Click Update Lists, and then after some time, the package manager will load all the available packages you can download. Let's go ahead and search for OpenVPN. And there's two that we're going to download. The first one is Lucy app OpenVPN. So you can go ahead and just install that. And then the second one is this one right here, OpenVPN OpenSSL. So you go ahead and just install that. With both installed, we should be able to see a VPN entry at the top of the web page in the navbar. Let's click on the VPN dropdown, go to OpenVPN, and then down here, we're going to upload our configuration file that we got from the EC2 instance. In the same location that you pasted the config, go ahead and click on it, and let's give it a name. I'm going to name it with the date, so 2022-08-29 config. We'll hit the upload button and we'll see that it gets uploaded and it's now an entry in the instances section. So we'll enable it and then we'll start it. Let's hit save and apply first. Cool, so now you can see that the instance started because this button here turned to a red stop. Let's go over to edit, check it out. It should look the same as what you generated with the public IP of the EC2 instance. So going back to OpenVPN, we can see that we were able to upload our config file and establish connectivity to the VPN. Now let's go ahead and define the third network interface, which you can find in the network dropdown and then clicking interfaces. We're going to add a new interface and I'm going to call this VPN in all caps. The protocol will be unmanaged and the device we're going to pick ton0, which is the network interface that talks to OpenVPN on AWS. So I'll go ahead and create the interface. Looks like it popped up, which is cool. It's nothing we have to do here. For firewall, we're going to create one, so we'll come back and assign it after we're done creating the firewall. But everything else looks good, so we'll go ahead and save it, and you can see VPN popped up here. Great. So now, in the network section, we're going to go ahead and go down to firewall, and we're going to add a new entry here in the zone section. So let's back out here. So down here, hit add. Going to have a firewall here. We'll just call it VPN. Do lowercase, why not? Everything will be accept. We'll do masquerading, and then for these two entries down here, we're going to do LAN for both, which basically means we want traffic to and from the VPN to be allowed by the LAN firewall. Everything else looks good, so we'll go ahead and save this. And you'll see that the LAN firewall gets updated because it allows forwarding here. I'm going to go ahead and check masquerading as well. And then let's go ahead and save and apply this real quick. Now, last thing is we'll go back to network and then interfaces. And we'll edit the VPN interface we just created. And in firewall settings, we will assign it to the VPN firewall entry that we just did. So go ahead and save that. We'll do save and apply. And that's it for the VPN firewall and interface. After creating our three interfaces, let's make sure we still have internet connectivity. So in a new tab, I'm going to just go to example.com. And you can see it pops up as expected. I'll also check my settings and make sure that I have the IP address with the expected subnet of 192.168.100.164. So things look good. One thing you may have to do troubleshooting in order to talk to the LAN from the VPN is go back to the OpenVPN section, stop the connection, refresh the page to make sure it's stopped, and then start it again. Be sure to restart the connection one time before actually testing it out. I'm on a Mac and I'm going to test being able to access this OpenWRT LAN remotely. So first step, open up your OpenVPN Connect. Could be from a Mac, Windows, Linux, doesn't matter. And then click the OVPN file that was generated on the EC2 instance. This has to be different than the one that you generated for the router, so make sure that's the case before you upload it. I'll just say learning OpenVPN and OpenWRT for the profile name. Go ahead and add it. Hit the switch. It should have connected. If you want to be extra verbose and make sure things work as expected, in the logs for when you connect, it should have a section for saying add routes. And you should see the subnet that we defined on the OpenVPN side. So now in the browser, if I go to 192.168.100.1, I'm already signed into the OpenWRT because I tested it before I recorded this, but you can see we can access it. This is great news. And then inside of the subnet, I also have a single client in the subnet with this IP address 164. So that's weird. Pasted 163. 164, there you go. And I'm running a really, really simple server that just has a single file on here. Before I click it, I'm going to prove to you that I'm not on the subnet. So this is all through the VPN. And you'll see that my Wi-Fi, I'm on the 192.168.1.230. Completely different subnet, so this is all legit. Refresh, nice. Let's go ahead and hit the test PNG. And there you go. Everything works great. Hope you learned something. All the other YouTube videos were really confusing on this topic, so I decided to make one myself. See ya.